Okay, I finished plotting the rest of my points for problem 2b. When you connect, you should see that you get almost the exact, well, you do get the exact mirror image on the other side of your axes. This graph is what all inverse graphs look like. Okay, they always have the x and y axis as asymptotes. Okay? The next problem, we're going to make the equation and do the graph again. I will pause the video to give you some time to plot your points. It says that x and y vary inversely. So right away, that leads me to understand that y equals k over x. That's step 1. Step 2, it says y is -7 and x is 8. Step 3, you got to multiply each side by 8. So -56 equals k. And then step 4 is to make your new equation, plugging in -56 on the top, and you have your brand new equation. Now, that is part A. That's what we just answered. What is the function? Part B, it says, what does the graph look like? Well, that's where we have to make that really annoying XY chart. In fact, we make 2 of them because we don't have enough room. Think of your factors of 56. Okay, let's start with the big factor, 56. Okay, go down. 56, then you go all the way down to, hopefully, 28. Keep going down. After 28 is 14. What else goes into 56? 8, 7, does 6 go in? No. 5, 4 does. 3, no. 2, and 1. These are all the factors, and I do this so we get nice numbers, everybody. These are the factors of 56. Now when I plug them into this equation, I have to do -56 divided by 56 and get -1. I have to do -56 divided by +28 and get -2. I do -56 divided by 14 and I get -4. And you just continue that down. -56 divided by 8 is -7. -56 divided by 7 is -8. -56 divided by 4 is -14. -56 divided by 2 is -28. -56 divided by 1 is -56. This chart, we have to do the negatives, okay? So I'll draw a little line to show a separation. I have to plug in -56, -28, -14, -8, -7, -4, -2, and -1. Why do I have to do both? So I get a nice picture. Okay, you have to do both to get a nice picture. I'm going to write that down. Have to do both to get a nice picture. Have to do both to get a nice picture. Okay, plugging those in, I do -56 divided by -56 is 1. -56 divided by -28 is 2. -56 divided by -14 is 4. And that continues on. You should notice they're exactly opposite of what's in the chart beside it. Okay, so you can really just copy your other chart and change your answers. Now what I'm going to do is I'm going to pause the video, I'm going to plot my points, and then we'll talk about our points. Go ahead and take some time to plot yours. So it looks like mine. Let's again skip by 5s on each axis. Skip by 5s. Okay, plotted all my points. Now what you should probably notice, the difference between this graph and the graph that we had last time is that this one's in exactly different quadrants. I'm going to let you think about that, why that happens. Okay, connect. Get a nice curve, and notice that the axes are again the asymptotes. Okay, and all I did is I plotted my points. Notice again that the axes are the asymptotes. Now here's my question. Why are they in different quadrants? Okay, let's answer that. y different than last graph? Well, I hope you answered that the reason they're different than the last graph is because k was negative 56. And that's always going to flip it to the two different quadrants, whereas last time k was positive. Let's move on to part C. Okay, part C says, what is y when x is 2? All we have to do, guys, is take our equation and plug in 2 then. And it's really just that simple. You would say y is negative 28. End of story. Let's move on to problem 3. Problem 3 is finally somewhere we can actually pick up and make it applicable to real life. Your math class has decided to pick up litter each weekend at a local park. Each week there's approximately the same amount of litter. The table shows the number of students and the number of students who worked each of the first 4 weeks of the project and the time. Now I hope you notice that the more students, the less time. That makes sense, right? As long as everybody's doing their share, the more people you have, the faster it should go. What is the function? What we need to do is we need to test this to be an inverse. So we're going to do the inverse test, and in order to do that, you're going to do x times y. Alright? So x times y would be 3 times 85. The next thing you'll do is 5 times 51. The next thing you'll do is 12 times 21. And then 17 times 15. You should notice in each and every one of those, you get 255. Just put it on your calculator, double check. Now this is approximately. They're all approximately multiplying by 55. Now when we go to part A and it says what's the function, I do notice that because this is true, it's an inverse function. So I'm going to do y equals k over x, and that's y equals 255 over x. Now they didn't use y and x, did they? They used n and t. So what we'll do is we'll say time equals 255 divided by n. And that is the function they're looking for. Now if you want to make it, what does that actually mean? It means the time it takes it's really like 255 if you have one student, okay? And then that divides out the less students that you have. Part B, how many students should there to complete the job in 30 minutes? Well, since this is minutes, we'll plug that in for t. So we'll do 30 equals 255 over n. Okay, so here it is, we plugged it in. Now we need to solve. So we'll have to multiply both sides by n. So we'll get 30n equals 255. And then we divide by 30. N is 255 divided by 30. 8.5 students. So we'll write 8.5, but you can't have half of a student. So we're going to have to round up to 9 students. And that's when we'll get below 30 minutes. That was a lot easier than graphing it, wasn't it? Okay, let's do got it number 3. Actually, let's do this together in class. That'll make sure everybody's head is kind of in the same spot and we're understanding what's going on. Okay, the next 4 problems we're going to do on a separate video.